For 7.2, Coral in the Sea, and for the rest of this lesson, we're going to start looking at application problems that experience exponential behavior, and we're going to look at what it means to have a negative exponent in terms of an application problem. So for this first one, Coral in the Sea, a marine biologist estimates that a structure of coral has a volume of 1,200 cubic centimeters, and that its volume doubles every year. Remember, when you hear that phrase doubling, multiplying, or taking half of something, that's an exponential growth, not a linear growth. So number one wants us to write an equation in the form of y equals a times b to the t power, representing the relationship where t is time in years, since the coral was measured, and y is the volume. So really, in order to know how to write an exponential equation, you just want to know these two things. What did you start with? And what is your growth factor? What are you multiplying by to get each new value? So we're starting with 1,200 cubic centimeters, and we're doubling. So our growth factor is timesing by 2. So when you write your equation, it's going to be y equals 1,200 times, in this case, our b value, our growth factor is 2 because you're doubling, and it's 2 to the t. Now you don't need that multiplication symbol in there. You're more than welcome to go ahead and write it as right next to each other, as long as you have the parentheses in there. So both of these will work. Now at number 2, they want you to find the volume of the coral when t is equal to each of these numbers. So I'm going to make a table of values, and we'll maybe open the screen up a little bit over here and make our table of values. So T is time in years. And then remember, we're measuring the volume in cubic centimeters. So even though they have a Y here, this is your volume. That's your dependent variable. And I will start with -2 in my table. They want -2, -1, 0, 1, and then they want you to go all the way, kind of skip a little bit and go up to 5. So we're going to go ahead and bring up put our initial value in. Our starting value at time 0 is cubic volume of 1,200. And we're doubling, so 1 year later, it's going to be 2,400. Now we want to figure out when time is 5. So I can keep doubling until I get up to 5, or I can just plug 5 in for t and figure out what that is in the calculator. So we're doing 1,200 times 2 to the 5th power, because I want to know at year 5. I need a calculator. So let me go see if I can bring up my calculator on this screen. This one will work. And go to my apps, and there's my calculator. So 2 to the 5th power. This one's not doing an exponent other than squaring on it, so I'll just do 2 times 2 times 2 times 2. What's that? 1, 2, 3, 4 times 2. So I've got 5 of them. 1, 2, 3, 4, 5. And then I wanted to multiply that by the initial value of 1,200. And hit enter. 38,400 would be my volume. So 38,400. And what do you think I should do when I want to go back? Right? So we got to raise this 2 to the -1, or 2 to the -2 power. So anything to the negative exponent is actually a fractional value. Because I keep multiplying, right, from my initial value, I'm multiplying by 2. And then to here, actually I was multiplying by a lot more to go from there to there. So if I want to reverse my table of values, I'm actually going to divide that previous number by 2. So if I take half of 1,200, I'm going to end up with 600 here. Let's go ahead and reverse it again. Take half of that or divide by 2, and you're going to end up with 300. Now, if you wanted to see that done with algebra, I'll show you. This would be 1,200 times 2 to the negative 1. Anything to the negative power is just a fraction. So this is 1,200 times 1 over 2 to the positive 1, which is just a half. And 1,200 times a half is 600. So I don't know about you, but I really don't care to put negative exponents into a calculator. So I'm going to use the concept that if I'm multiplying to work up my table of values, then I'm going to divide to work down my table of values. So we found all our volumes. What does it mean? So for number 3, what does it mean in this situation when t is equal to negative 2? So when t is equal to negative 2, so that's 2 years. Because this isn't a negative, it's 2 years before you started. Let's come back up here and figure out what t was again. T is time in years since the coral was measured. So when they say t equals negative 2, this means 2 years before. So 2 years before we measured the coral. We can expect the volume. So if we go to our table right here, we can expect the volume to be 300. We can expect the volume to be 300 cubic centimeters, so centimeters cubed. So now let's move on to number 4. In a certain year, the volume of the coral is 37.5. So at some time, put a little question mark there, the volume is equal to 37.5. Remember, y is the volume. T is your time or your x. I can even put an x there if you want. When do we expect this to happen? Well, if I go to my table and I start to reason it out, it's going to have to be, we're going to have to keep going back in our table, right? At negative 2, we're at 300. So let's keep our table going. So at negative 2, we're at 300. And to go backwards, we're going to divide by 2. So at negative 3, half of 300 is 150. At negative 4, half of 150 is 75. At negative 5, half of 75 is, half of 70 is 35, 36, 37.5. So I really just continued the pattern in my table, and I went backwards because they were asking for a really small volume amount, and I know moving forward we're doubling. So I've got my time right there. So I would say 5 years before measuring the coral volume.